Hello, so in this video I will explain you about what is a linear regression technique. Basically, linear regression is a technique which is used in statistics and machine learning to predict the values of one variable on the basis of other variables. The value to be predicted is called dependent variable, and the variables on the basis of on which we try to predict, those are called independent variables. When the number of independent variable is only one, then it is called linear regression. Whereas when the number of independent variables is more than one, then it is called multiple linear regression. Consider an example of when we try to predict the value of house on the basis of factors like area of the house, number of rooms in the house, and the number of floors in the house. So there are four variables in this. The value of the house is the dependent variable, whereas the rest of the three is independent variables. So when you are trying to predict, and in this case the value of house on the basis of rest of three independent variables, then it is called multiple linear regression. Whereas when you try to predict the value of house on the basis of only one variable, say value of house as a function of area of the house, then it is called a simple linear regression. Now let's consider we want to predict the value of a single variable y on the basis of other variable x. Then y will be dependent variable and x is independent variable, because x can take any values as it changes, whereas y is a function of x. So when x changes, how the y changes. That's the purpose of doing the linear regression. Some points to be noted in linear regression is that for a given value of x, there are many values of y, and that is why we try to predict the mean value of y for a given x. That means if you see in the graph, for a given value of x or for a given fixed value of x, you see that there is a distribution of y. That means there are a lot of y values. There is not a one-to-one mapping of x and y. So for a given value of x, you get many values of y. So there is always, for the distribution of y, you have a mean and a standard deviation of this y distribution. So when you are doing a linear regression, you try to predict the mean value of y for a given value of x. That is one thing. Second thing is the optimization of linear regression, where you try to minimize the residuals. By residuals, I mean to say the difference between the actual and the predicted values. You try to minimize, you try to fit a line in such a way that it minimizes the residuals. That means the errors between the actual and the predicted values. This best line is obtained by several methods. One of this method is called ordinary least squares. There are a lot of techniques in regression, types of regression techniques. One of this is PCR, principal component regression, partial least squares, polynomial regression. So these techniques are developed to tackle with different kinds of problems which comes across when we have different kinds of data. Some of the problems which we will discuss are, and also these are the assumptions. So when you are just doing a simple linear regression or multiple linear regression, there are assumptions in that. So first assumption is linear relationship, then multivariate normality, then multicollinearity, autocorrelation, and homoscedasticity. So I will talk in brief about all of these. First is linear relationship. That means the coefficients of the variables, of the independent variables, coefficients have to be linear. That means the coefficient should not be squared or cubed or other polynomial orders, whereas the variables can be squared or cubed or other polynomial orders. So keep in mind, in linear regression, the coefficients have constraint that they should be linear. whereas the variables can be squared. So you can have in model like x square x cube, whereas the coefficient which is beta in the model that should be linear, that should not have higher order polynomials. Second is multicollinearity. Multicollinearity means that there exists some relationship between some of the independent variables. That means when we have say 3 independent variables, you can say, for example, it's not for sure, but for a given data set, when we are talking about a house, it can be like when the area of the house is very large, then the number of floors tends to be more, are more probable to be more. It's not necessary, but say for a given data it's like that. When the area of house is getting larger, the number of floors are also getting larger. So there is some kind of multicollinearity. Cannot be, it's not that it is perfect collinear, but there is some relation between them. If the area of house is large, then the number of floors in the room, floors in the house is also large. So that is a multicollinearity that shouldn't be present in the linear regression technique. Third is homoscedasticity. That means the errors or the residuals variance should not vary for a given values, for any values of independent variables. So it should not increase or decrease. The variance should stay constant. Variance of not y, but the variance of the errors. That means the difference between the actual and the predicted values. That is the residual, and we are talking about the variance of that. So variance of the residual should stay constant. That is homoscedasticity. And the error distribution should be normal. That means the residuals which we obtain after fitting the once we fit the line to the data, we get the actual values. We already have the actual values in the data. We have the predicted values which are predicted by the values points on the line. So difference between the actual values and the predicted values are called as errors or residuals. Those residuals should have 0 mean and the standard deviation as 1. That is the error distribution normality. So these are the assumptions in the linear model. As one of the conditions are not fulfilled or these are violated, the model will not be stable at all, and also the coefficients of the models which are fitted will not be stable at all, and the model cannot be interpretable. Cannot be interpreted means we cannot say that for a given change in x1, what is the change in y? That won't be constant, that won't be stable at all. So these assumptions should be followed, if not completely, but should be followed strictly in order to get the model results or predictions to be stable, and the interpretation, these all assumptions should be followed. In the later videos I will be explaining more in detail how to understand all these things in detail, all the assumptions, and how to do linear regression in R or Python. I already have videos on R and Python, so you can have a look on the channel so that you can learn more about how to do actual machine learning in R and Python. So thanks for watching this video, and please do not forget to like and subscribe so that you get the notifications when I make more videos on your like. So thanks for watching. Bye bye.